If you've been taking chemistry for any period of time, you know that the statement on the screen is very true. Sometimes things don't go as expected in the laboratory. For example, you might be carrying out a chemical reaction and you find that something like this happens. Maybe you do a calculation ahead of time and find that you should be able to make about 100 grams of a product. But then once you get into the laboratory, you do the reaction and you find that for some reason you only make 65 grams, just as an example, or you might make even less than that. So something unexpected happens. Now, why is that? Well, sometimes it's difficult to collect a product. Sometimes there might be side reactions in which one of the reactants is reacting with oxygen in the air or something else, and it's just very difficult to make as much product as you thought you were going to make. And so we have two different numbers here. We have this actual yield. That's the amount of product that we really, actually in real life, produce in the lab. That's generally going to be smaller than what we thought we were going to make. The actual yield in this case is 65 grams. And then there's this other number. That's the theoretical yield. The theoretical yield is the amount that we calculated that we should be able to make. That would be the 100 grams in this case. Or as I like to say, it's the answer to a stoichiometry problem. And so in all of our previous videos about stoichiometry, we've been doing calculations with our three-step process, with the limiting reagent problems. Every answer that we got was a theoretical yield. When you carry these products or these reactions out in a laboratory, you're probably going to get less than that. That's the actual yield. So we have these two values, actual yield and theoretical yield. If we put those two numbers together, we make what's called the percent yield. And this is the equation for determining the percent yield. It's equal to the actual yield divided by the theoretical yield times 100. Now let's do a couple examples and see how we can calculate the percent yield for a reaction. In this reaction, it says that it is calculated that 17.9 grams of product should be produced. However, in the lab, only 15.6 grams are actually produced. Determine the percent yield of this reaction. Well, as we learned earlier, percent yield is found by taking the actual divided by the theoretical times 100. And so the actual yield, as we can see, is 15.6 grams. That's what's actually made. So that goes in the numerator of this reaction, or of this equation. And then in the denominator, we're going to put the theoretical yield. It says that we calculated that 17.9 grams should be made. So that's our theoretical yield, 17.9 grams. And of course, we're going to multiply that by 100. And then when we key that into our calculator, and we find out the actual percent yield, we find that it's about 87.2%. And so that's the percent yield in this particular process, about 87.2%. That seems pretty easy. Let's try another example, one that may be a little bit more challenging. In this case, we have a balanced equation, and we have this process. It says that 460 grams of sodium is reacted with excess chlorine. If 1,110 grams of sodium chloride are produced, determine the percent yield of this reaction. Well, as you can see, we have an actual yield that's given to us. It says that we actually make 1,110 grams of sodium chloride. That's what's produced. But does the problem tell us the theoretical yield of sodium chloride? It does not. And so that means we're going to have to go through a three-step process and determine the theoretical yield. And we're going to have to do that using the reactant that's given to us, 460 grams of sodium. So that means we're going to have to write 460 grams of sodium over here. And we're going to have to go through the process and find out how many grams of sodium chloride we can make from that. So we have to go through the process. Step one is convert to moles. So moles on top, grams on the bottom. And 1 mole is equal to how many grams of sodium? Well, it's about 22.99. We can round that off to the nearest tenths place and say 23.0. Cancel grams, top and bottom. The next step is the mole ratio. So we need to have sodium Na on the bottom and NaCl, sodium chloride, on the top. And the mole ratio is 2 to 2 this time. So we can cancel sodium. We're now in moles of sodium chloride. We need to be in grams of sodium chloride. So we have to do step 3, which is convert to final unit. And so moles on the bottom, grams on top. And how many grams are in 1 mole of sodium chloride? Well, we have to add the two values there. And so if we add 22.99 and 35.45 and round that off to the nearest tenths place, it's about 58.4. And so moles cancel once again. And now we just key in the arithmetic here. So we take 460 times 2 times 58.4 divided by 23 divided by 2. And the answer that we get is something very close to 1,168 grams of sodium chloride. So you might have an answer that's a little bit higher or lower than that depending upon how you rounded for your atomic masses, but that's okay. This is the theoretical yield, 1,168 grams. Now we go back to our equation and remember that percent yield is actual divided by theoretical times 100. So the actual yield was in the problem 1,110 grams, and then the theoretical yield we just calculated is 1,168 grams. And of course we multiply that by 100, and when we key that in, we get an answer of very close to 95%. And so we can say that our percent yield in this case is about 95%. 95.0 actually. So hopefully after doing these examples, you can see that determining the percent yield of a reaction is actually is fairly simple. We just have to know the actual yield and the theoretical yield. And in some of our more difficult cases like this one, we may have to use stoichiometry to determine the theoretical yield.